Hey guys, in our first lesson, we're going to be talking about one of the foundational things to statistics, which is the type of variables that we use. So here is the roster from the Buffalo Bills from ESPN, and you've got the different players. Now, for the different players, you'll have the player name, their jersey number, position. So Josh Allen is a quarterback. He is 30 years old, 6'5", 237 pounds. He has 9 years of experience in the NFL, and he went to Wyoming. So for example, position, you have different positions, quarterback, running back, etc. And when we analyze something like position, we're going to analyze it differently than something like age. So the first type of variable we're going to be looking at is a categorical variable, which describes different categories. So for example, someone's blood type, someone can be type O or type AB. And if you've got a bunch of people, then you're not going to be averaging those. But you can put them in different categories and do something like a pie chart to look at, what percentage of people have a certain blood type. So examples of categorical variables are whether your dominant hand, whether you attend church regularly, and in this case we want to define what we mean by regular church attendance. Opinion on marijuana legalization. You've got a couple options: in favor, opposed, not sure. So you've got three different options. Someone's eye color. Assuming that we've got these 7 different categories. Teacher rating on a scale of 1 to 7. This one's, if you define a scale from poor to excellent, 1 through 7, then this can kind of move into potentially, there's a way to quantify these. What I mean by that is, assign numbers to different ratings, and then we can use quantitative variables. So a quantitative variable is either numerical or has to do with counts. So something like height is measured, for example, measured in inches, and you can have all sorts of, when we're measuring someone's height, we can be fairly exact. So we can say someone is 6 foot, 2.5 inches, or 2 3/4, et cetera, et cetera, et cetera. Whereas if we're looking at missed classes last week, that's going to be a number like 1, 2, 3, 4, 5. And you can't really, technically, you're not going to miss 1.5 classes. For something like siblings, we definitely, you wouldn't say you've got 1.5 siblings and 1 3/4. These are discrete counts. So a continuous variable is a variable that every value within some interval is a possible response. So an example of that is weight. I can be as specific to my weight as my tool allows me. So if I step on a scale, it can give me 2 decimal places, 3 decimal places, 4 decimal places. On the other hand, a discrete variable are only countable sets. So for example, how many speeding tickets did I have last year? 0, 1, 2, 3, 4. I wouldn't really say that I have like 1 3/4 speeding tickets. So raw data for quantitative and qualitative and categorical variables are summarized differently. It makes sense, for example, to calculate the average number of hours of sleep last night. So I could talk to my class and say that, ask everybody how many hours they've had of sleep and then find the mean of that. On the other hand, for blood type, it doesn't make sense to find the average. And there, I would want to look at the percentage of people that, for example, have an A+ or a B+ blood type. So we're looking at proportions or percentages of the group who are in each blood type category. So review the data below and identify the type of variable for each of these. What type of eye color? So this would be categorical. How many siblings? This would be quantitative and discrete. What is the height in inches? This would be quantitative and continuous. How many miles is your hometown from Blacksburg? Again, this would be quantitative and continuous. I could say it's 5.5 miles, or 5 miles and 3/4. Did you vote in the last presidential election? This is a simple yes or no, so this would be categorical. Would you support a casino built in Roanoke, Virginia? Strongly opposed, slightly opposed, neutral, slightly support, strongly support. This again would be categorical. How many hours of sleep did you get last night? This would be quantitative and continuous. We can also have explanatory and response variables. When we have a relationship between two variables, one of them, the explanatory or independent one, and one of them is a response or dependent one. So the value of the explanatory variable might partially explain the value of the response variable. So the idea is we're using one of the variables to try to predict or have some sort of inference on the other one, on the response variable. The identification of one variable as explanatory and the other as a response does not imply there's a causal relationship. So just because we think there is some sort of input-output relationship between the two doesn't mean that one causes the other. It simply implies that the knowledge of the value of the explanatory variable may help provide knowledge about the value of the response variable. So, for example, if I look at, let's say I've got the football roster of the Buffalo Bills, and I look at all the different player heights and then all the different player weights, I see that there is a relationship between height and weight. So the idea there is, in general, I expect that as a player gets taller, we expect them to weigh more. Now, there are some players, for example, this player, and so this is player A, here's players B. Player A is taller than players B, than the two players in B, but the two players in B weigh more. So it's not a causal relationship, but in general, the explanatory variable here, the height, as height increases, we expect weight to increase as well. Let's do a couple of practice problems. Which of the following is the best example of a continuous variable? Number of siblings, eye color, height measured in inches, classes missed last week. So height measured in inches. A researcher studies whether height explains differences in weight. In this relationship, weight is the, so the idea is we're trying to figure out if height explains differences in weight. So weight is the response variable. It's the one on the y-axis. Identifying height as the explanatory variable and weight as the response variable implies that height causes changes in weight, weight changes causes changes in height. Knowledge of height may help explain weight, but it does not prove causation. The two variables must be categorical. So we think that height may explain weight, but does not prove causation. So does not prove causation. A student asked, would you support building a casino in Roanoke, with the response options being as such? The variable is best classified as continuous quantitative, discrete quantitative, categorical, or explanatory. So these are categories, and they would be best shown using a bar chart or a pie chart. How many siblings do you have produces which type of variable? Categorical, continuous quantitative, discrete quantitative, or explanatory. This would be a discrete. Discrete basically just means that things are separate. So 1, 2, 3, 4 discrete quantities are separate. All right, so that is an introduction to variables.